Copyrights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Hello students, welcome to S-Chand Academy, the official YouTube channel of S-Chand Publishing. The book here is Mathematics for IIT-JEE Main and Advanced by M.L. Khanna sir. I am Subuh Nadeem presenting you the videos. And the concerned chapter here is the 35th, which is the last chapter. It is of the volume 2 of the book. Its name is Mathematical Reasoning. So if we talk about the theory part of this chapter, so that is basically starts from the definition of a statement. So what is an statement? It is a sentence which is either true or false. True or false sentence is called a statement. It can't be both, it can't be neither. Okay, for example, sun is a star, it is a true statement. For example, Rohan is a good student. It is sometimes true, sometimes false. Why it is sometimes true, sometimes false? Because it is depending upon who is telling about Rohan and with whom he is comparing. So if we say Rohan has a marks 90% more than in 10th board, then it is a true statement. And if he has not got more than 90%, then it is a false statement. But a good student is not a statement. So there are logical connectives which we have to understand here. What are those logical connectives? Like we have and. If we talk about and, then it combines two statements. For example, Rohan is boy and Rohan is honest. So this is here and the and here is actually represented by this symbol, and this is a connective. So Rohan is boy is a statement P, Rohan is honest is a statement Q. So we say P and Q is a conjunctive statement, and this is a logical connective. Next we have, if we talk about P and Q, then P has truth values true or false. Similarly, Q can have truth value true or false. So there will be how many combinations? There may be 4 combinations, like P is true, Q is true, P is true, Q is false, both are false, P is false, Q is true. So if we talk about P and Q, what would be that? True and true will be true. If two statements are individually true, then their and is also true. If one is true, another is false, then the combined statement is false. If both are false, then also it is false. And if again one is false, another is true, then it is false. So this is called mathematical reasoning, and in this is called and, which is the conjunctive operator. Next we have or. What is or? Or is basically represented like this. It means Rohan is good boy or Rohan eats burger. So these are two statements, P and Q, and there is a or. So what does it mean? That if a statement says Rohan is good boy or a statement says Rohan eats burger, so in that case, if we take P, Q like this, mathematically if we make the truth table, again the truth table will be something like this, and then we see P or Q. So if any one of them is true, then it is true, and if both are false, then it will be false. So this is a truth table of or statement. Then there is an implication. The implication says that if a statement P implies Q, or we can also say like this, P implies Q, then we make the truth table of P and Q. This is called if then also. If this is true, then this is true, like this. Or if this is false, this is false. So true, 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 false, false, true, false, false. If you make a statement P to Q, what will happen? True to true is true, true to false is false. Here it is true, here it is true. So this is implication. Another is double implication. I am making double implication here only. If suppose R and S are two statements and we are making double implication, then its truth table will be like this. This is R, this is S, and I am making R double implication S here. So what will happen? I am making these entries here. So true to false is actually false, and false to true is also false. This is true, this is true. So actually double implication can also be understood like this, that we have an implication from both the sides. So if we are saying R double implication S, this means this is equal to R implication S and S implication R, like this. So if you make a table of R implication S and S implication R, this is S implication R, not same thing. So what will happen if you take AND of both of this, then you will get R double implication S. Now in the next one, you can talk about tautology and fallacy. What is tautology and what is fallacy? So basically, before doing this question, we come to tautology and fallacy. Tautology is a statement which is always true, and fallacy is a statement which is always false. Fallacy has another name also, it is called contradiction. So fallacy or contradiction, this has a name and it is always false. Now we have another question here which we have to see. So the question says here that not of P double implies Q is. So let us draw the truth table here. So P, Q. We have taken P, we have taken Q, two statements. True, false, true, true, false, true, false, false. These are the possibilities. Now if we talk about P double implication Q, we have already done this, and negation of that. So true to false is false and negation of that will be true. True to true is true, negation of that will be false. False to true will be false and negation of that will be true, and here we will get false negation. Now which will match with this? If we take not of P and not of Q, so false and true will be false. So this has not been the right choice. This is false, this will be true. False and true will be false, but this is true. So this is not the right choice. If we talk about not of P or not of Q, so this is false, this will be true. If we take the negation, then it will be true. That is fine. Here also false and false will be false, or true or false will be true. Here true or true will be for true. So it is not the right choice, because here this will be not validated, others will be validated. Now we talk about P and not Q, or not P and Q. So let us do this truth table here. P and not Q, and not P and Q. If you take this one, so P and not Q, so true and true will be true, and true and false, not Q will be false here. So false, false and false will be false. Here false and true will be false, right? Not P and Q if you will take. So false and false will be false. False and true will be false. True and true will be true. And here true and false will be false, like this. Now if we take the or of both of them, P and not Q, or not P and Q, like this. So what will happen? If you take the or, true or false will be true, false or false will be false, false or true will be true, of course, false or false will be false. So does this match? True, false, true, false. So yes, this one and this one is matching. So we say that option C is the correct option. Both have the same truth table. So they are equivalent statements. Let us come to the next question. Which of the following is logical equivalent to not of not P to Q? So here again we will apply the same truth table. So here as we go, not of P to Q. So we take P and Q first. So what will happen? True, 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 false, false, true, false, false, like this. Then we take not of P implies Q. So not of P implies Q will be false to true. False to true will be true. Then false to false will be true. Then true to true will be true. And true to false will be false. And then we take not of this. Not of P implies Q like this. So this will be false, 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 true. And then we match with the following statement P and Q. So P and Q, this will be true. So this is not validating. Let us first row, even this first row is not validating it. P and not Q. So P and not Q, true and false will be false. True and true will be true. Second row is not validating in this case. Not P and Q. So not P and Q is false here. False here. True here. So it is also not validating. Third row is not validating here. Not P and not Q. So here it will be false and false will be false. False and false will be false. False and true, sorry. False and true will be false. And true and false will be false. And true will be true. Yeah. So option D is the correct option. That is validating. It is a logically equivalent statement. So you can do it mentally if it is a small, and if it is big, then you have to make the truth table. Otherwise, you can do mentally also. But you have to at least write the entries of P and Q. So you are writing this truth table here again. If P and not R implies Q or R is false and Q and R are both false, then P is. So it is saying that this statement is false, right? So if this statement is false, so we have to move backward. So P and not R implies Q or R is a false statement. So if it is a false statement and it is given that Q and R are both false, so Q is also false, and if we take R, it is also false. Both are false. Q and R are both false. Then P is. So Q or R, if you take Q or R, then in that case, you get this as false in this situation. And you are saying that the resultant is false, then this must be true, because in implication, true to false is false, others are true. So if you take Q or R, that is false because both are false, and this should be true. Now not of R, this not of R is basically true because R is false. So this is true. So if we are saying that P and not of R is true, so what is the final result? P and not of R is true, right? And we are saying that not of R is also true. When does it possible? Only if P is also true, then true and true will be true. Otherwise, if you take P as false, then it will not be true. So you will say that P is true. This will be the correct statement. Let us move on to the next question. If SPQR is equal to not P or not Q and R is a compound statement, then S not P not Q not R is. So S not P not Q not R is equal to, as from this definition, it will become P or Q not of Q and not of R, like this. You will get that this not of P will become P if you take not of P in place of P, negation of P, not of Q will become Q here, and not of R will become R here. Now if you evaluate this, this will become P or Q or R, because De Morgan's law says that not of A and B is equal to not of A or not of B. So and becomes or if you put the negation on both of them. So this will become Q or R. Now P or Q or R, if you see all the statements here, so this is not P or Q or R. This is also not the same. PQRS is also not the same as we know here. So this is also gone. Now let us see this one. What is this? If we talk about S of P, Q, not of R, what will happen? It will become not of P or not of Q and not of R, like this. Again, if you calculate this one, this will become not of Q or R. So not of Q or R will not match with this. So the correct result should be, if you take this one SPQR, then as you can easily see that this is becoming P, this is becoming not of Q and not of R. So this is becoming Q or R. So P or Q or R should be the correct statement. So I would suggest that we can change this option and make it as P or Q or R, which is the correct option. Even B option was also there. So B option is also not matching. So we can make one option correct by changing this. Let us come to the next mathematical statement. Not of P or Q or not of P and Q is logically equivalent to. So let us make the truth table here. Not of P or Q and not of P and Q, like this. And then we finally take the OR of not of P or Q or not of P and Q, like this. So if we take these two truth tables, we can take the OR and find the last truth table. So let us take true, true, false, false, true, false, true, false, like this. So P or Q is true, whereas its negation is false. This is also true, its negation is false. This will give you false and this will give you true. Now in the second one, not P and Q, what will happen? This will be false, this will be true, so you will get false. This will be false and false, you will get false, and true will be true. And here true and false will be false. This is what you are getting. Now take the OR. So false or false is false, false or false is false, false or true is true, and true or false is true, like this. So what do we get here? That if P is true, we are getting this statement as false. So what were we observing? If this is false, this is true, and if this is false, this is true. So can we say that it is negation of P? So we can say yes, it is negation of P. So option A is the correct option. Let us come to the next question. If P, roses are red, this is the P statement, and Q, the sun is a star, then the verbal translation is not of P or Q is. So if you make the verbal translation, roses are not red, that is not of P, fine, and the sun is not a star, that is not of Q, so it is not Q. It is not true that roses are red, this is fine, this is negation of P, or the sun is not a star. So the sun is not a star is negation of Q, so you can't take this one is also. Roses are not red, that is fine, or the sun is a star, the sun is a star is Q, so you can take this option. So you can do this orally without solving it mathematically, because here truth table is not required. Let us come to the next question. Let S be a non-empty subset of R. Consider the following statement P. There is a rational number X belonging to S such that X is greater than 0. the negation of p is. So important thing is there is a rational number. Rest of the thing you won't get confused, but there is a rational number negation. When you will do, you will get confused. So what you have to understand here, that if you take the negation of this, you want the negation of this. So there is a rational number x belonging to S such that x less than equal to 0. Everything seems fine, but there is a rational number is not the negation of there is a rational number. There is no rational number x belonging to S such that x less than equal to 0. This is also not negation. So this two will vanish. This C says every rational number x belonging to S such that x less than equal to 0. So this you will take because there is a rational number such that x is greater than 0. So you will take every rational number such that x is less than equal to 0. So opposites of this is x is less than equal to 0, and there is every rational number such that x is less than equal to 0. Let us come to the next question. The next question says the statement P implies Q implies P is equivalent to. So if you take here the statement, so again you have to make the truth table. So if we make the truth table, we get P, Q, and Q implies P, and then P implies Q implies P, like this. So this will be true, this will be true, true, false, false, true, false, false. Now Q implies P will be true, this will be true, this will be false, this will be true. Now P implies Q implies P. So this will be true, this will also be true, this will be true, and this will be true, of course. False to true is true in implication. Now we have these statements. P implies P or Q. So if you take P or Q, what you will get? You will get true, 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 false, like this. And P implies P or Q if you will take. So what will happen? True to true will be true, true to true will be again true, false to true will be true, false to false will also be true. So you are getting everything true here. So in the first option itself, you are getting the correct answer. So you need not check other options. P implies P or Q and P implies Q implies P. Both are tautology. These are tautology. So you will say that option A is the correct option. Let us move on to the next question. Which of the following statement is a tautology? So again, you have to make truth table for all of them. So let us start making truth table. P and Q is there, and then we have true, true, false, false, and then true, false, true, false, like this. And then we have not of P and Q. So not of P and Q will be false, and this will be false, this will be true, this will be false, right? And then we have and Q. Not of P and Q with Q. So what you get here? False, and of course it is not a tautology. So this exception goes. I'm not calculating other part. Not key Q and P, P and not P. So P and not P is actually false. The and statement between negation and the statement is false. So this is false, and if you are taking it with anything, either it is true or false, it will be false. So this is also not acceptable. It is not a tautology. Next we have P or not P. That is true always, because it is a or between a statement and its negation. And then we have not Q and P. So this will be a tautology. Whether this is true or false, the or will be true. So option C will be the correct option. Right, students? I hope you have got it. Let us come to the next question. Next question says, consider the following statement. P, Suman is brilliant, Q, Suman is rich, R, Suman is honest. The negation of the statement Suman is brilliant and dishonest if and only if is there. This is a double implication here, if and only if Suman is rich. So how can you write it? By the help of mathematical conjectives. So what you will do, Suman is brilliant, that is PS statement, and dishonest. So you will say and not of R, that is Suman is not honest. And then we have if and only if. So you will apply double implication like this. Only Suman is rich, that is Q. So can you write it like this, the mathematical statement? Of course you can write it like this. So this will be P and not of R double implies Q. And negation of that, you have to write negation of it. So negation of this one. So again, if we take the negation of this one, so what we can talk about here is P and not R double implication Q and a negation of this. So if we choose the correct option will be, if we put a appropriate bracket here, because there might be a mistake of typing. So this will be complete, this bracket and this bracket will be complete. So this option B will give you the same thing. You can either write this one or this one. So Q double implies P and not R, and that statement is same because you can always say that R double implies S and S double implies R is the same thing. So you can apply this double implies Q or Q double implies this. Right, we have the next question again. So that is all for today's lecture, students. These questions are quite helpful, and go through the book. Thank you everyone.